Electric arc welding is one of the most widely used methods of metal fabrication. Its major emphasis is employed in the construction areas of aircraft, automotive, space exploration, nuclear energy, and large buildings, to mention only a few. Arc welding is the process of melting and fusing metals together by means of heat created by an electric arc. This forceful arc penetrates deep into the base metal. Its heat is over 6,000 degrees Fahrenheit. Obtain permission from your instructor before using the welding equipment. Make sure there is ample ventilation. There are two basic types of arc welders, AC for alternating current and DC for direct current. The following procedures may be applied to either type of arc welding. This 250 amp arc welder provides for both AC and DC. To form an electrical circuit, it consists of a ground clamp and cable, an electrode holder and cable. Then when a metal electrode is placed into the holder and the current turned on, an arc may be produced anywhere on the welding table. Avoid welding such as this on the table. Make sure the cables are not overlapping one another, or a magnetic field is built up, thereby affecting the resulting weld. A treated leather apron and gloves should be worn when arc welding. Welding jackets should be used for out-of-position welding. Safety goggles should be worn under the specially designed head shield helmet, which is easily adjusted to fit one's head. For general arc welding, the darkened glass is shade number 10, which will protect your eyes from the invisible ultraviolet and infrared rays produced by the arc. One should never look at the arc with the naked eye within a distance of 50 feet. The goggles used for oxyacetylene welding are not strong enough to provide proper eye protection. All arc welding should be done behind a screen or curtain. A special chipping hammer and wire brush will also be needed to chip and clean the slag from the weld. Electrodes are generally classified into 5 main groups: mild steel, high carbon steel, special alloy steel, cast iron, and non-ferrous. An electrode is used to form the arc. It is a metal rod with a coating of chemical substance. Both the metal rod and the chemical coating melt along with the base metal to produce a strong bond. The chemical coating stabilizes the arc and protects the molten metal from oxidation. The size of an electrode is measured at the bare end. Beginning welders should check with their instructor for the type and size of electrode to use. The current should be regulated before welding. There are recommended current settings for all electrodes, but only through skill and practice will the welder learn the best current setting. An approximate current setting is equal to the decimal value of the electrode diameter. For example, if a 1/8 inch electrode is used, the decimal equivalent is 125 thousandths, and the current setting can be 125 amps. This is 1 amp for every thousandth of an inch. Insert the electrode into the electrode holder. The thumb should be able to release the electrode easily. Current may be on or off. The wrist and forearm are used when striking the arc. Keep your elbow close to your side. Body weight should be balanced and legs spread slightly. To begin welding, strike the arc using one of 2 methods. The tapping method, preferred by most experienced welders, or the scratching method, used by most beginning welders. Regardless of the method used, right-hand welders find it easier to weld from left to right. Opposite weld direction is used by left-handers. Small work should always be clamped to the welding table. Position the ground clamp cable away from the heat of the arc. Your head shield helmet must always be lowered before striking the arc. Give your wrist a sharp twisting action to free an electrode stuck to the base metal. If this fails, remove the electrode holder from the electrode, turn off the current, and break loose the stuck electrode from the base metal. This may also be done with your gloved hand. After striking the arc, lean the electrode into the direction of travel, approximately 15 to 25 degrees. Notice the vertical electrode position is seen from the end view. Although exaggerated, this view does show that down-feeding of the electrode is necessary during welding travel, as it is consumed when it joins with the base metal. Generally, the length of the arc is about the same as the diameter of the electrode. The welder must maintain this arc length during all welding. Variations of this technique may also be used. Some electrodes permit the use of a slight drag technique, whereby the electrode is lightly dragged through the molten weld being produced. There are 4 main positions in arc welding: horizontal, flat, overhead, and vertical. The beginning welder should learn to weld in the flat position first. These essentials of arc welding should be well understood by all welders. Correct electrode. Let us begin with a 1/8 inch mild steel electrode, properly inserted into the electrode holder. Correct current. Using 1/4 inch mild steel plate, set the current to 125 amps. This might vary somewhat on different welders. Correct arc length. Again, the arc length should be no greater than the diameter of electrode being used. In this case, approximately 1/8 of an inch. Arc length should be carefully maintained. Note the molten metal piling up on the left. Correct travel speed. The welder should attempt to produce 1 inch of bead for every inch of electrode used. Most beginning welders travel too fast. When possible, use your free hand to help steady the hand holding the electrode holder. A good welder will watch the molten crater, the finished bead solidifying directly behind the crater, as well as the path ahead of the bead during welding. Avoid watching the arc itself at the tip of the electrode, even though protected by a colored welding lens. Make sure the red color has disappeared from the weld bead before chipping the slag from the weld. Too early an exposure from the surrounding air will absorb oxygen and nitrogen, which is apt to cause weld contamination. This slag, formed by some of the substances in the chemical coating, floats out the impurities in the molten metal and forms a protective coating to prevent oxidation. If the current is set too high, the electrode melts too fast and the molten pool is large and irregular. Undercutting and excessive spatter will also be noted when the current setting is too high. This is a correctly made weld bead at lower amperage. If the current is set too low, there is not enough heat to melt the base metal and the molten pool will be too small. It will be difficult to strike and maintain the arc. A narrow bead with poor fusion is the result when the current is set too low, again as compared to a correctly made weld bead at proper current setting. Even if the welder is set at the recommended current setting, another poor weld will result when the arc length is too long. Metal melts off the electrode in large globules, resulting in severe spattering. In addition, poor penetration will occur. The result is quite obvious when comparing it to the correctly made weld bead. An arc that is too short fails to generate enough heat to melt the base metal properly. The electrode is apt to stick frequently. The result is a high uneven bead with irregular ripples as compared to the correctly made weld bead. Travel speed, which is too fast, is a common error with beginning welders. The weld bead usually is narrow with pointed ripples. On the other hand, if the travel is too slow, metal piles up excessively and overheats the base metal. Note how wide this bead is, as compared with our correctly run weld bead. Use the electrodes until they are consumed to about 1.5 to 2 inches long. Never attempt to weld in a cluttered area. Keep flammable materials away from the welding area. When you have finished, turn off the welder and hang up the electrode holder in its proper location. Never leave it laying on the floor. Avoid quenching any welds which will undergo any testing. Write hot on your metal with a piece of chalk to prevent others from being accidentally burned. AC and DC arc welding are only two of the many varied types of electric welding being performed in today's industry. Before attempting to arc weld, it is recommended that additional reading and research be completed. Follow the manufacturer's recommendations and all safety rules. If in doubt, never guess. Always check with your instructor.